Good morning. Hi. I hope everybody's having a wonderful day. Um, I'm recording in the morning. That's why I keep saying good morning, but good afternoon or good evening, whenever you see this video. My name is Miss Hernandez. Today, we're going to be talking about Wednesday's assignment, Wednesday the 16th. I initially had planned for us to do 3.8 and 3.9, but after first and second, I realized that it's not going to happen. It's not going to happen because dimensional analysis is pretty difficult. So maybe not difficult, but it takes a lot of effort to get to know dimensional analysis. So students, if you go click on your CK12, you can go in there, sign in using your Google account, and it will easily let you into here so that you can see all the videos and examples and all that good stuff. But if not, remember I've already attached the PDF version in today's assignment. Okay, so there's no excuses. Okay, so dimensional analysis. Let's get started. Now, dimensional analysis is really, really important because this is what we use to change from one unit to the other. The actual value does not change. Okay. So if I have a meter stick, you know, those yardsticks that teachers like used to point in classes, well, that yardstick can have different values. Okay. It can be 1 meter. It can also be 100 centimeters, or it could be 10 decimeters, or it could be 1,000 millimeters. Okay. This is why we mean that the value doesn't change. It's just the unit that is being asked of us to present it in. Okay. The English system makes things so complicated. Why does the English system make things complicated? Well, because the numbers that are associated with some of our units aren't very easy to remember. Okay, and I was trying to highlight that because I wanted you to take notes, but it's not letting me, so it's okay. Here you have an example of the English system and some measurements that all equal the same value. Okay, so if you have 4 cups or 2 pints or 1 quart or 0.25 of a gallon, it's all the same. Okay, it is all the same. You still have a quarter of a gallon. Okay, if you were to pour 1 quart, the volume would still be the same. Just like we said about the meter stick being 1 meter, 100 centimeters, or 1,000 millimeters. If you fill up an empty gallon container and you only put 2 pints, you're going to get 0.25 of a gallon. If you only put 4 cups, it's still going to be 0.25 gallons. If you put 1 quart, the volume will still be 0.25 gallons. But the thing about the English system is that um, it doesn't work very, very well as far as remembering the numbers. Okay, so the metric system is what we use in science because it's easy to remember. Okay, everything's base 10, so the only thing I have to remember is, okay, which one's the bigger value? That's going to be my 1. Which one's the smaller value, and how far away are they? Okay, if you're talking about kilometer, well, the kilometer will have the 1, and the centimeter will have a million or 1,000 or whatever it is. Okay, anything below that kilometer, that always has more as far as numbers go compared to a kilometer. Okay, so if we were to compare the kilometer, 1 kilometer would equal 1,000 meters. Okay, and how do I know that? Because it takes 3 steps to get, or 3 steps down to go to that base, to go to that meter. Okay. And if I go 10 to the 3, well, that's just saying 10 to the 1,000. So there are 1,000 meters in 1 kilometer. Okay. And that's real easy to remember, unlike the English system. So the metric system uses the powers of 10 for all conversions, making life for us chemists and scientists much, much easier. Okay, and here's an example of ratios that use this metric system. Okay, if for some reason you're trying to convert meters to centimeters, both of these are the same length. If you measure 100 centimeters and 1 meter, it's gonna be the exact same length. Okay, so 100 centimeters will equal 100 centimeters, 1 meter will equal 1 meter, and all of these fractions all equal to 1. Okay, this fraction is what you call a conversion factor. Now, the actual definition of a conversion factor is a ratio of equivalent measurements. Okay, because both 1 meter and 100 centimeters represent the exact same length. I can take out my measuring tape, I can measure it, and I can say, ooh, 1 meter. Oh, look, it also says that it's 100 centimeters. Oh, look, it also says that it's 1,000 millimeters. Okay, that is what's so awesome about the metric system. Since the numerator and the denominator represent equal quantities, their value, all are valid conversion factors, all of them equal to the same length. Now, let's talk about actual dimensional scientific dimensional analysis, okay? So, conversion factors are used in solving problems in which a certain measurement must be expressed with different units. Okay, let me lower myself down. When a given measurement is multiplied by an appropriate conversion factor, the numerical value will change. Okay, but the actual size of the quantity measure remains the same. Now, what do they mean by that? Okay, so we go to our Jamboard. Okay, so this is our Jamboard. If I wanted to do an example for you, and I say, okay, well, what if I have 5 meters? What if I have 5 meters? And I want to change my meters, instead of them being in meters, I want to change it to kilometers or centimeters. Okay. So I'm going to put a 1 underneath because it just helps remember what I have to do in the next step. Okay. Every single number I give you is always going to be over 1. Okay. So now I need to think, okay, if I'm changing 1 meter into centimeters, well, I know centi is 2 levels down. 10 to the 2 is like saying 100 centimeters. Okay. Now, if I want to change it, I have to put this unit. Oh, I'm sorry. I need to change this unit right here, meter, and I need to make sure that this unit cancels with this 1 meter. So I need to decide now, is my meter going to go here, or is my meter going to go on bottom, top or bottom? Now, if you remember back from your math days, if you have, for example, 2x over x, well, that just means that there are 2x's on top and 1x on bottom. Okay? So anytime that you are dividing by the same variable, this 1x that I have here will cancel one of the x's that I have here. So instead of having 2 on bottom, I'm only going to have 1. Okay? Now, if I would have had x on top and x on bottom, well, both of them would cancel out and I'm left with the number 1. Okay? But in this case, we are going to cancel out those meters. Okay? So what are we going to do? We're going to put 1 meter on bottom. And the reason why I'm going to do that is because this unit will cancel with the original unit. Okay. Now that I've canceled that unit, I'm going to use the remaining information to change it to a new unit. Okay. The one that they're asking me for, or that I'm asking you for, the centimeter. Okay. Now, if I multiply 100 times 5, I should end up with a value of 500 centimeters. Okay, and did you notice I did not just put 500, I indicated my final unit, which in this case was the centimeter. What did not get canceled? Okay. All right. Now, the thing you always have to remember, if my numbers are on top, like you have here, I'm always going to multiply. But if my 5 would have been up here and my 100 would have been on bottom, I would have had to divide. Okay. Opposites, we divide. Same side, top and top, we multiply. Top and bottom, divide. Side to side, multiply. Got that? Okay. Now let's go back. Now it says that dimensional analysis is a technique that uses the units or dimensions of a measurement in order to correctly solve problems. And then they offer some advice. Dimensional analysis is best understood with an example, and they gave us an example. They said the sample problem for dimensional analysis will be how many seconds are in a day. Okay, so the first thing you need to know is you need to list what you already know. Well, what do we know? Well, we know one day has 24 hours. 1 hour is made up of 60 minutes, and 1 minute is made up of 60 seconds. Okay, so now this is my unknown. What do I know? I know that they want me to change one day into seconds. Okay, so I've already attached this to our Jamboard over here. And this is our dimensional analysis sample, the one that they have in the book. Okay, so we're going to start with the information that they gave us. And the information that they gave us is this one day. Okay, so I'm going to put 1 day over 1. Remember, your information that they give you in the problem is always over 1. Okay, and it helps you understand what you need to do on the next line. Okay, so we're going to start with bullet number 1 because bullet number 1 has days. Okay, now I need to decide, where am I going to put those days? Am I going to put it on top or am I going to put it on bottom? Well, I'm going to put 1 day on bottom. Okay, that way it can cancel out. And I know 1 day is equal to 24 hours. Okay, so then I extend it. And now I have hours. So I'm going to use the second bullet. 1 hour equals 60 minutes. So where am I going to put hours? I'm going to put hours on the opposite side. Since I have 24 hours on top, I'm going to put the 1 hour on bottom. So it can cancel out my hours. And now I'm left with these 60 minutes. Okay. So then I put another line and I'm going to use the third bullet that says 1 minute equals 60 seconds. Okay, where am I going to put my minutes? Well, since it's the 60 on top, I'm going to put my 1 minute on bottom. And I'm going to put 60 seconds on top. My minutes are canceled and I'm left in seconds. So what's my answer? Well, the only thing that's left to do is to actually multiply. Okay, so I'm going to get my calculator. I'm going to put 1 for 1 day. And since everything is on top, I know that if everything is side by side and on top, I'm going to multiply. So 1 times 24, 24. 24 times 60, 1440. And 1440 times another 60 gives us an answer of 8,600. 86,400. I'm sorry. So when I write my answer on my Jamboard for here, I'm going to write 86,400. And I'm not going to just need the number. I'm going to add seconds. Okay, and I'm sorry, that box is horrible. That is dimensional analysis. Okay, we are gonna continue. Okay, So if we look at theirs, you can notice that they have the same answer as we do. But the only thing that I would find confusing is this 1 day right here. This 1 day doesn't really make sense, because if I don't put that one that I keep suggesting, I don't know if I have to put 1 day on top or on bottom in order to cancel it. So if you use, like I suggested, the one on the information that's given over one, we know exactly, okay, on the next line, in order for me to cancel days, I need to put them on opposite sides. Okay, that's the only difference from mine and theirs. Did they get the same answer as we did? Yes, we did. We ended up with the 86,400. Okay, so now now we know conversion factors is a ratio of equivalent measurements. Dimensional analysis is a technique that uses dimensions or units of the measurement in order to correctly solve problems. Okay, you're more than welcome to watch these videos. Remember, just sign into CK12 and use your Google, and you should be able to use the link that I provided in the assignment. So this is your review. What is the conversion factor? What is dimensional analysis? And then how many meters are in 33.7 kilometers? And then how many kilograms are in 12,980 grams? Okay, so I'm going to give you some extra information over here on the Jamboard to help you with those last two. Okay, let me clear this one out. So the first one says 3.7 kilometers. Okay, so you have 3, and there's a 0.7 kilometers over 1, multiply, set up our next one. Now I'm going to tell you that 1 kilometer is much longer than a meter. And if you remember earlier, I said 1 kilometer is equal to 1,000 meters. Okay. First thing you need to do is you need to decide where kilometers need to go. Now, remember, kilometers is here on top. So, where does kilometers need to go? Pause me so that you can think. But you have to remember, in order for me to cancel this out, I need to put kilometers on bottom. If I put kilometers on bottom, they easily cancel out. And then I can put my equivalent of 1,000 meters on top. Side by side, remember, side by side, we multiply. Opposite sides, we divide. Okay? That is for this one. For the next one, and you could pause it right here, but I'm just going to clear it. For the next one, they give you 129.80 grams. So you have 129.80 grams. Remember, always put it over 1. I am going to tell you that 1,000 grams is equal to 1 kilogram. Okay? I'm not going to help you with this one. It's very similar to what we've been doing. So try it out on your own, and I will see you tomorrow. Have a wonderful, wonderful day. Bye-bye.